my name is Angela, and today we are going to be doing the Chem 126 Interactive Advanced Concept Presentation with nuclear bombs. And so in this video, I'm going to be explaining how nuclear bombs work, the reactions that occur internally and make the explosion, and then the explosion itself. So first, we're going to talk about the inside, so the internal chemistry that occurs. So first, we need to address what makes the nuclear bombs, the essential ingredient to making the nuclear bomb, which is uranium. It's found naturally in nature, and there's two different types, 235 and 238, and we are going to try and separate these two isotopes to make this nuclear reaction. So we only need 235. And so what uranium ends up going through is a separation process, and this can be done through a gas chamber. And so uranium goes through this chamber. It's a cylinder with high and low energy to separate the two isotopes. And so these two isotopes have different weights. And so the high energy is going to be with the 235, and then the low energy is the 238 isotope, and then so they separate. And it can also be done through centrifuge. So as I've mentioned before, these two isotopes have different weights. So it spins the uranium in the centrifuge, and so the heavier isotope floats down, and then the lighter isotope floats up. The energy contained in atomic nuclei is released during nuclear reactions, and the chain reaction of the fission of the heavy nuclei is what causes the explosion. So as I mentioned before, uranium-235 is used, but an alternative is isotope 239, which is used to build plutonium bombs, but it is really rarely ever found in nature, as opposed to uranium, and so most of the time it is synthetic. What makes the explosion is the mass of fissile material is concentrated in a single space. So inside the bomb, it's packed tightly, and it's called critical mass. So as you can imagine, the bomb is like this oval shape, right? And this like mass inside of it, and it's called critical mass. And once critical mass is reached, the nuclear decay reactions occurs in the presence of a release of energy. And so to make a really destructive bomb, 4 to 5 critical mass is needed. And the main way to achieve this is called implosive. And it's a guided reaction, which is an explosion on the outside of the nuclear shell to increase the density of heavy nuclei until the nuclear explosion starts. So it kind of showed it really well in the video where it was like this central point of uranium and these like segments of uranium outside. And so you have this explosion on the outside that's like caps the nuclear bomb that gets detonated once a trigger occurs. And so when this reaction occurs, it makes all these segments of uranium concentrate towards the center. It gets pushed towards the center, and so it reaches critical mass, and then the nuclear explosion starts. And so when making this weapon, you only need 40% uranium and 60% projectile. And so the projectile is that cap. And so it makes the atoms separate.